Okay, let's get started. Let me switch on this. Okay, hello everyone. Welcome to the INTAREA working group, IETF 125. I'm Wasim Haddad, co-chair, and with me today is...
I'm Carlos Bernardo from UC Dream.
So let's go quickly through the chair slide. Note well, I think by now you have seen this slide many, many times. Just a quick reminder, you have all consented when you participated in the meeting to follow our code of conduct. Please keep in mind the session is being recorded. Make sure you sign using Meeteco and use Meeteco to join the mic queue. And please make sure your audio and video are off unless you are chairing or presenting during a session. So the agenda is available on the link that you can see. And our agenda today, we have 6 items. We're gonna see again the problem statement for the cross-layer vulnerabilities due to forged ICMP error. And we are gonna see a new draft about ICMP query for node information and a broadband network user plane specific information sub-option for the DHCP relay agent option. And we have a draft about extending ICMP for multipath and a presentation about the DNS at the IETF at the end. Quick housekeeping. So want to remind you, please, that each time we start a working group plus call, it's very, very, very important that we get at least 5 reviews to progress the draft. We have had some issues before with some draft. It's not enough to say, yes, I support, it's good, but not good enough. We would like to see people really reviewing and providing feedback for the authors so we can move the draft forward. Finish the working group plus call. We have a draft that is waiting for an updated version, the RFC 8335 bis. The shepherd is waiting for the authors to submit an update, and then we can push the draft to submit it to the ISG. And we have 3 drafts already submitted to the ISG. So let's get started. The first presentation, Carlos. Yes, please, Eric.
So go on stage, by the way, if you want to go. I was just about the 3 drafts that are missing. The proxy is being currently in the IG evaluation. It will be most probably approved in early April. The node ID, I'm waiting for a revised ID to approve it for more than 100 days now. So I don't know what's happening there. And the V4 next up by V6, AD review has been done. I will start I think even the last call has been started. So we are progressing well. Just the status.
Okay, thank you. You will take notes? Okay, thank you. Okay, first presentation, please come. Carlos, can you use the remote? Yeah.
Yes. Okay. Maybe you have to turn on the mic. No.
Okay. Hello, everyone. I'm Li Zhaoxi from Tsinghua University with my colleague Ao Wang. And I'm here to present problem statement for cross-layer vulnerability due to forged SMP errors. As we all know, SMP is an Internet essential feedback mechanism, but it has an inherent challenge. The validation against SMP error is weak. The attacker can easily forge SMP error to deceive the victim TCP stack. Based on our research, we classify four cross-layer vulnerabilities: information disclosure, state synchronization, semantic validation deficiencies, and source authentication failures. The first one is information disclosure, which means a lower layer field unintentionally expose upper layer secret. This is example, IP-ID side channel. And a forced SMP error can forces the victim IP layer to change its IP-ID generation policy. And it creates a side channel where the IP-ID leaks information about TCP layer events. The attacker can observing the IP-ID increment and then infer the TCP sequence number to do TCP session injections. The second one is state desynchronization, which means the protocol layer has an inconsistent view of shared resources. There's a good example, IP fragmentation injection attack. A forced SMP error can desynchronize the path MTU between the IP and the TCP layers. This causes TCP to generate segments that are unexpectedly fragmented. The attacker can then inject a malicious IP fragment which incorrectly reassemble with legitimate ones, and this will cause a packet injection. The third one is semantic validation deficiencies. The meaning is a protocol receive a control message that it cannot fully validate. The example here is SMP redirect traffic hijacking. The attacker can forge UDP datagram and a corresponding SMP redirect message. And the victim stack check the embedded header in the SMP message, find a matching but forced flow, and accept it and redirect. This semantic gap in validation leads to traffic being hijacked. Now, last but not least is the source authentication failure. The meaning simply is a lack of source authentication allow attacker to impersonate a trust network entity, like a router or access point. The example here is wireless network routing cache poisoning. The attacker can impersonate AP to send a forward SMP redirect to victim on a Wi-Fi network. The message contains a crafty UDP payload to bypass validation check. The victim accepts the redirect, poisoning its routing cache, and make the attacker its new gateway. All subsequent traffic is redirected through the attacker, who can intercept or manipulate it.
So what is the mechanism? As stated by my colleague, SMP error messages for stateless traffic are easily forged by outpass attackers. To fix this, we propose challenge confirm mechanism. Here is how it works. First, the challenge. Upon receiving an SMP error message, host B embed a stateless and computed nonce in the next ongoing packet for the flow. The nonce is a hash of secret key and flow information. Second, verification. As you can see in the left diagram, a real on-path router sees and reflects the nonce, proving it's on the path. However, on the right diagram, an outpath attacker never sees the nonce and cannot forge a valid response, so the attack fails. Then we have a summary of all updates for the past IETF meetings. So after IETF 122, we try to answer 3 questions about state storage, amplification attack, and the packet lost. And in IETF 123 and 124, we also try to resolve 3 questions. Question 1, why not just check the embedded packet? The reason is that the check only works for stateful TCP. Since its headers contain secrets like sequence numbers that are hard for an outpath attacker to guess. But for stateless UDP and SMP, the headers have no secrets. They are trivial to forge. This is exactly the vulnerability we are going to fix. The draft now better emphasize this. Question 2 was about story-based document style. We have rewritten the document to be a direct technique specification. And question 3 was about multipath routing. What if a packet take a different path? In a single event, the challenge will miss the original router, and the host receives no confirmation and ignores the SMT error. But what happens next is a stateless recovery. Since our mechanism is stateless, if the application sends another packet that hits the same error again, a new SMT error is generated. This restarts the process. A new independent challenge will be sent. A new section rewritten is added to discuss this problem. That's all about our revision. We're welcome to collaborations and comments. Thank you.
Thank you. Any question, comment? Yeah. Ron, go ahead.
A quick question about the nonce. You said that it's computed from a shared secret. How does the secret get shared?
We try to simulate the mechanism like sync cookies. The secret key may be a secret key used like in sync cookies. It may be a secret key maintained in a system. It may be refreshed several minutes once a time.
Does this mean if the attacker could observe the SYN cookies, he knows the shared secret?
Yeah, if the attacker knows the secret key, it can attack the mechanism. But the secret key is maintained in the system level, so it's a hard thing to steal the secret key.
Doesn't it have to be shared as part of the session? It's not pre-shared ahead of time, is it?
Yeah, it may be shared by different session. We will take this problem into our future consideration. We not consider this secret key may be used by the host and shared by different connections.
We use hash to generate a session secret, so it also it's hard to doing the invert. You cannot to infer the secret from the shared keys.
And our target is off-path attackers. For off-path attackers, it's a difficult thing to have such a secret key on the host. It typically cannot observe traffic between between two hosts in communication.
Okay. Any other question? Thank you, gentlemen. Next item. Ron, are you going to present?
Thank you very much.
Sure.
Okay. If we could go to the first slide.
You have the control.
Oh, I don't see where I have it. Could you?
If you want, I can run for you, no problem. So,
Okay, thank you. Okay, we would like to introduce two new ICMP messages for a very specific purpose. Let's say one peer wants to ask a question of another, any question. We'd like to introduce two new messages, a query request that requests information from a node, and a query response that responds to it. It's generic for any question in the world. Next slide. What's the syntax? Both messages include an ICMP extension structure. An ICMP extension structure includes objects. We will define many objects. Each object represents a piece of information. So the object identifies the question that it's asking and leaves a little space for the answer. So you send a query with the object, you get a response, the object, or possibly, its response flavor comes back to you. And there's an example of this in draft IETF 6-man ICMP v6 IOM configuration state. It's a way to ask questions about the configuration state, IOAM configuration state. And we will define many new objects as needed, one for each new question. Next slide. So a few more things. The query request and response are defined for both ICMP v4 and v6. Like all ICMP messages, they must be rate limited. And in fact, these might be rate limited more strictly than other ICMP messages. Not so much because we're worried about the bandwidth that it might take to service these, but it might actually require some CPU to figure out what the answers are. So these might be rate limited a little more strictly. And the query response must not be longer than the corresponding query request. This prevents amplification attacks. Next slide. Why did we use a new ICMP message type? We had two options. One was the information request. We didn't use that first because it was deprecated, and second because we couldn't put an extension header in it. It was only good for the information that it requests today, or that it used to request yesterday. And why didn't we use the extended echo request and extended echo reply? First is because we didn't want the ping semantics that those messages bring with us. Second, there's some confusion around those messages as to whether the extension structure is the last member in it. Because people have implemented those messages in funny ways, probably we shouldn't use them anymore for anything. Next slide. The next slide is an ask for review and comment. Also, we'd like to adopt this as a working group item as quickly as possible. And the reason why is at least one other draft depends on it already. The draft that we mentioned a couple slides back about IOAM state. And that's it. Questions?
Thank you, Ron. Any question?
Hi, Ron.
Yeah.
Hi, Jen.
Yeah, can you hear me?
Yes.
So I quickly looked at the draft, and after your slides, I have a question. So you're going to deprecate 8335 or what?
You mean, does it duplicate 8355?
Yeah, like extended
Okay.
pin.
In very many ways, it's like 8355.
Yeah, but
in fact,
it's not generic. So are you going to get rid of the previous work, or?
well, with 2020 hindsight, we should have done this generic query response back then. But back then I was thinking about only ping and came up with something that was much less generic than we should have had. Now, it's actually possible that you can put an interface identification object in these two messages, and they could replace the extended echo and extended response. But since extended echo and extended response is widely deployed, probe is widely deployed, we might as well let them continue doing what they're doing. And for all new applications, we'll use this generic message.
Okay, so I don't remember what your security consideration section says. It's kind of a bit scary when you say you can ask whatever. I'm just a bit afraid that people might like block it just in case because they don't want to explicitly enumerate what your router could tell you and what could not or should not.
I forget exactly, but I think there is a response for each object. One response is, I don't support this object. Another response, if it's not in there, it should be, I do support this object, but I don't want to tell you the answer to the question you're asking.
Yeah, I'm more thinking about, like, let's say I have a router, how do I configure that stuff, right? So we probably need to be like a little bit more specific about that, right? Do we
Yes.
want by default like everything to be, I'm not gonna tell you anything and permit explicitly and so on? That's just my concern. But yeah, okay, thank you.
Dave.
Dave?
Hey, Ron, can you hear me okay?
Yes.
Yeah, so I have a similar-ish question, but mine is about RFC 4620, which is the IPv6 node information queries, which is a generic object in that sense that it contains, the ability to have multiple types, not just addresses. And it does have replies that you can say, here's the reply. You can say, I'm not going to tell you, and you can say, I don't know. So those things it does have. It's experimental, but it's 20 years old. And so I guess my suggestion to you would be, in this document, you should have maybe a section on prior work and how this is different and whether it obsoletes those or whatever, because clearly, I mean, the one that I'm talking about was experimental. You could say, well, this is the replacement for that experiment, or this uses that experiment, or here's the failures in that experiment. Right now, you don't reference the RFC that Jen was talking about or this one. And so I would say, what's the difference? And it would be great if the answers were in the document, because right now it looks like it's duplicating the intent of 4620, maybe with some improvements, admittedly, but it's really duplicating the intent of that one.
Okay. Let's see. If it's 4620, it predates the extension object. So there's probably a good reason why we want to do something new so we can have different objects in it. Thank you very much. We'll put in a section that talks about 4620 and 8335.
Okay, thank you. And so I can't comment on the Adopters working group item until I see the differences and stuff, and then I might have an opinion, but right now I don't have any opinions. So thanks, Ron.
Okay, thanks a lot.
Thank you. Any other question? Okay, thanks, Ron. Third item. Is Shen Yang in the room? Okay.
Good afternoon, chairs and experts. This is Chen Yang Wen from China Unicom. The title of my presentation is Broadband Network UP Specific Information Sub-Option for the DHCP Relay Agent option. And other authors include Lin Zhu and Yutao Zhang. So this draft has three main parts. The first one is Broadband Network UP Specific Information Sub-Option. This part include the format of UP-specific information sub-option.
Excuse me. Go ahead, Eric.
So Eric Vink, no head. I read briefly the draft, and I'm pretty sure many people in the room have no clue that app means user plan. If you are not in 3GPP, you don't know. For me, it was upstream, but UP, it's user plan, right?
Yeah. So we can supplement.
I had the same issue.
So let's continue. In the first part, UP-specific information sub-option include format and sgrp ID and UP identifier considerations. And the second part is DHCP relay agent behavior, and third part is DHCP server behavior. So let's start with the motivation and the problem statement. In the control plan and user plan separated broadband network architecture. User plans backup function as multiple UPs to the same UP backup group, forming a backup or load sharing relationship between multiple UPs. And sgrp is a group of subscribers together that share same backup state. So we think the best practice is the same sgrp on a specific UP shall be assigned addresses from the same address segment. So there is a question. Since the DHCP server cannot know the subscribers are born by which UPs, it may assign addresses from different address segments to subscribers on the same UP, which is not conducive to address aggregation on the UP. So in this draft, we add a sub option to the DHCP packet, enabling the CP to add GRP information and UP information involved in the DHCP request messages. So let's move on to the format of UP specific information sub-option. These three figures show the format of DHCP messages, relay agent information option, and sub-options. So based on this, we designed the format of broadband network UP-specific information sub-option. The fields include code, length, reserved GRP ID and UP identifier. GRP ID means the ID of GRP, which should be any integer value between 0 to the power of 32 minus 1. And the UP identifier means the identifier of UP, which currently carrying the group of users and corresponding to the GRP ID. So next, the considerations of UP-specific information sub-option. The first one is GRP ID considerations. The GRP ID should be fixed, and the CP, which is a DHCP relay agent, should use the single identifier value constantly for a GRP. And the sgrp ID used by a relay device should be committed to send to stable storage unless the relay device can regenerate the value upon reboot. So second, UP identifier considerations. The UP identifier should be fixed and unique. And if the UP identifier configured in the relay agent is not unique within its administrative domain, resource allocation problem may occur as the DHCP server attempts to allocate the same resource to subscribers behind two different UPs. Then UPs cannot implement IP prefix convergence. Let's move on to the DHCP relay agent behavior. The DHCP relay agent is assumed by the CP, and the DHCP relay agent should be configured to include the relay agent information option when relaying DHCP messages. In order to support the UP-specific information sub-option, and the DHCP, the IGRP ID should be correspondingly to the IGRP configuration parameters in the board-bound network CP. The UP identifier can be loopback address of UP or other identifiers. As for DHCP server behavior, this sub-option provides additional information to the DHCP server. If it is configured to support this sub-option, the DHCP server may use this information to first divide the address pool into a small block using the IGRP ID and the UP identifier as indexes. And second, allocate an address in the address block indicated by the IGRP ID and the UP identifier. Next steps, we will consider the impact of this sub-option on network security and solicit comments and refine the draft. That's all my presentation. Thanks for listening. Questions and suggestions are welcome. Thank you.
Thank you. Any questions, comments?
So Eric Vink, responsibility for INTAREA. I think we talk about it by email. Do you intend to also, as long as the DHC working group exists, I think this draft would be better suited in DHC. Now, DHC working group will close most probably in 1 year or 2 from now. So depending upon the timing, it may end up in INTAREA or stay or move to DHC. DHC working group is not meeting this week, so that's a nice way to present it here. Reading the draft, there are many, I think, very specific terms like UP, SGRP, I guess it's subscriber group, but as the reader, if you want to get good review from this draft, which is mandatory for call for adoption, you need to be sure that it's readable. So all the specific acronyms that are there, like AN, I guess it's access network, but I don't have to guess when reading a draft, right? So I need to be sure, needs to be cleared, right? So you need to really to explain everything there. Another point that kind of scares me, if you go back on a couple of slides, one of the first one, when you were showing the packet format, the one before this one, I think, it's, oh no, yeah, the one you get, it takes time. It's obviously a DHCP v4, right?
Yes.
And do you intend as well to do the same thing for DHCP v6?
Maybe we will consider it a next step. Maybe we can consider in IPv6 next steps. We haven't considered this.
So now, putting back my responsibility at, it will never be passed to me, right? At the IAG evaluation, it does not support v6, just to be clear, right? So it's most probably that's very easy to do, but it will not pass. Okay.
Okay. Thank you.
Thank you, and thank you for the work.
Okay. Then please ask for feedback on the mailing list, because we haven't seen any activity on the INTAREA mailing list. So it would be good to continue the discussion. Okay.
Okay. Okay. Thank you.
Sure. Okay. Thank you. Next item. ICMP. I don't. Okay. It's here. It's good.
Good afternoon, everyone. This is Li Zhang from Huawei. I will introduce our work on extending SMP for multipath. Okay, here is the introduction for traceroute. Traceroute use SMP time exceeded message to collect the nodes information along the route, including the IP addresses and the host name of nodes and other informations. Based on that, RC 48 and 84 redefine some the SMP message to support multi-part operation. It defines a new extension structure at the end of SMP message to carry the additional message. RC 58 and 137 extends the SMP message with an interface information object to carry the interface information, including the if index, IPv4 addresses, IPv6 addresses, the name, and also the MTU. And in addition, the RC 83 and 35 defines a tool which is named probe, which is used to query the status of an interface by sending SMP intended each request message. Each reply message includes a state field to reflect the state of the ARP table or neighbor cache entry to indicate whether the interface is reachable. So the motivation for our work is that the traceroute is typically used to collect the information of a single path. When using traceroute in a multipath topology, which means we can have multipath to the destination, then the traceroute can only get one of the path information, and don't know that there are other paths that can go to the destination. So as shown in the figure below, there are 6 nodes and there are 2 paths from node A to node F, and the ECMP is enabled in node B. Then the traffic can be forwarded in both paths. But if we use traceroute to get the forwarding paths, we can only get one of them. So if there are some mistakes on or problems on another path, then the traceroute is very hard to locate that. So we define a new SMP extension object, which named the multipath interface information object to collect the multipath or the multi-interface information. In this object, we define a C-type. It has a C-type which indicates the types of the interface information. It can be an IPv6 interface or an IPv4 interface. And then it has a sequence number and a total number, which indicates the sequence of this interface and the total number of the interface that can be reach the destination. And and we also have an information indicator which controls the following multipath interface information in this object. That can control the interface if index, the IP address, and the name MTU, and also other informations in the following. So the multipath interface information carries the detailed multipath interface information as specified in the information indicator field. So for the information, this document reuses the if index IP address name and MTU formats that already defined in RC 58 and 37. The next hop and the state information is new in this object. For the next hop bit indicates that whether the IP address subobject exists for the next hop, And if both the IP address and the net hole bit are set, then the two sub-objects must be placed in order. And we also have the state bit, which indicates the state, the interface state sub-object is included. The format of it is the same as defined in the probe tool. Okay, and so since this is the 0.0 version, so I would like to ask whether the motivation and the use case is clear, and whether it is faced in the INTAREA working group, and we also would like to collect the comments and suggestions to improve the document. That's all. Thank you.
Thank you. Any question, comments? Eric?
Eric Rinken, no specific yet. As you asked for, is it clear? So, clarification question, if you don't mind. So it's still an ICMP return message by extension done on hop limit exceeded, right? So you get information only on one node.
Yeah.
How do you detect then that you are using a different path?
Yeah.
If you can come back on the slide with the topology.
This one?
Yeah, this one, yeah.
Yes, so if we, with this extension, the node B will return there are two interfaces information, right, for 2C and 2D. Then the trace route can, in the following trace route packets, it can use a different UD port number to let the trace route packet go through another path.
Yeah, but the node generating, if you do a trace route, let's say from A to F, the node generating the ICMP with this specific option will be the router F on the right-hand side, correct? But how does it know if there are switches? It has no information about the layer 2 path. Only the switch E, if it's a switch, it will never generate a hop limit exceeded. Or is it a router as well, the E?
Sorry, I didn't get your question. What's the matter with switch E?
So I don't understand.
So for the trace route packet, you add the TTL error time. Yeah, and for example, you generate a SMP packet and you from A to B and to C and to E and to F. F is the end, is the destination node, right?
No, actually, maybe there's a misunderstanding here. But a normal trace route, you send packet from A to G or H, which is not even on the picture, with varying hop limits, or TTL if you are using a PV4. And all the routers, not switches, routers, layer 3 device, when they forward it and they find the hop limit becoming 0 or 1, depending upon the version, they generate an ICMP error, right? So is it what you are doing? And that's routers, layer 3 device. So now maybe your graphic is wrong and you should have put in routers than switch.
Yes, I think it's wrong. Maybe we should put it, we should write routers.
Okay. But then you will get, in this case, you will never get, if the trace route, I mean, the packets with the varying hop limit follow the path A, B, C, E, F. Node D will never receive such a packet, right?
Yes.
It will never.
It will not.
It will not, right?
Yes, not.
So even with the option, I don't know how you can get the information.
with this extension, the router B can return the interface information that I have two interfaces that can reach the destination. I have interface to C and I have interface to D that both of them can reach to destination as well.
So if you do the trace route, and sorry if I understand very slowly, when you do the trace route from A to F, that's the node B, which is a router that will send the information which is useful.
Yes, yeah.
It will say there are two in my fib. I got two entries, for instance.
Yes, I have two interfaces.
Ah, okay.
Yeah.
Thank you. You may want to clarify this in the draft with maybe one example, because honestly, right now, I mean, on the slide, it's not really clear.
Okay, thank you.
Thank you for the explanation.
Okay, thank you.
Okay.
Next item, DNS is less.
So I'm not Wes Adaker. We went way too fast on the agenda for once. Typically, we are late. Just to tell you that Wes Adaker is still talking on DNS op. I ping him. So what I would suggest, I mean, the intention of this part is that DNS is critical to the internet and to the IP layer, pretty much like ICMP. DNS is currently mainly done in working group like ADD, DNSSD, DLEC, and DNSOP, with most of the work during protocol maintenance and protocol extension done in DNSOP, which is in operation, which is in a group which is overloaded. They're having 2 sessions per week, for instance. So there were a talk initiated by Matt Bukader, which is the Ops area director, to maybe reconsider how DNS working groups work at the IETF. So we started a consultation, and basically Wes, Joe, and Lehman were running it. They produced a draft. This was really indicated into the slide there. It was presented into the Ops area. So I think it's critical for the IP layer. I wanted to have it presented here as well.
I suggest, Eric, we can pause until he's ready.
Yeah. So I would suggest we wait 5-10 minutes.
Yeah.
We go look at the PC and nothing else to do, right? There is no coffee anyway. So
Yeah, why not?
and let's say if it's not done at 5:30, then we stop.
Yeah. Okay.
Some people are more occupied than others.
Here he is.
Here.
You can turn your camera, I guess.
Okay.
Yeah.
Yeah, and I should log in so I can get slide control.
You can get voice slide control, I guess.
Yeah, there's not that many slides. So if the chairs will put up with it.
Wait.
Unless you can give slide control to the room, that's actually a good thing. Okay. Are we ready? Sorry for being late and getting out of another discussion in DNSOP that was equally as entertaining.
Louis, the floor is yours.
All right, thanks. So this is a recap of sort of the work I have done in the last 6 months or so, along with Joe Abley and Lars Lehmann, to collect a lot of opinions about how DNS structures at the IETF are working or not working. This will go a little bit faster than I think if you watched it in OpsArea the other day. I'll go over the background, the process, and sort of the results. The background is the DNS is used very widely in the entire IETF. It's discussed in many working groups because it really is the bootstrap for pretty much everything. A lot of various DNS working groups have existed for quite a while in various forms. Those way back in the day may remember the DNSX working group. And there's a lot of hallway discussions wondering, should we go back to something with a split sort of decision about, should we have DNSX for protocol development and DNSOP for operations and things like that? Is it a problem in the first place? Should you have one large working group? Should you have a bunch of small, tightly focused working groups? And what would work best for the participants that wanted to comment, work, engage in particular drafts? And so the IESG asked me last summer to see if I could, find if there was a common opinions on the subject. So the approach I took was I gathered feedback. I reviewed all the feedback. We looked for commonality among all the feedback, and we crafted recommendations, documented the results in an internet draft. And then today, we are discussing the results. So this is where we are today. And then after this week, I'll take any final, suggestions and then put them and give them to the IESG. I'm not making decisions. I am only passing on what I've heard to the IESG. So for information gathering, it came from a number of places. There was a mailing list that people contributed to. I got some private email that I promised to anonymize. I had a lot of hallway discussions at the last IETF. And then there was one large discussion in the OpsArea meeting. It resulted in a 118-page document that I handed to 2 fellow co-authors in order for them to help me, not be the single person that tried to distill all this information. So that plus the OpsArea video took a lot of reading and trying to coalesce information out of it. So what was the commonality? Well, so first off, is there a problem? The answer to that is both yes and no. No, things do get working, right? We do publish RFCs, but a lot of people felt frustrated with the process and didn't think we were using the most efficient, path for our time, or that some documents were not progressing in the ways that they should. So really that came down to one large working group, tends to struggle to handle the breadth of all the document types. That was the prevailing opinion. Not everybody had that opinion, but it was a prevailing opinion. So splitting the work up into a development working group and an operations working group would sort of help that situation. In addition, the other prevailing opinion was that a DNS-specific dispatch group would be highly helpful. But working group structures can't solve the human, related problems of, there will always be disagreements. There will always be, hey, I come up with the best idea and maybe it's not. There's always a lot of, strife between people and things like that. There is no structure that can solve that, right? But one of the big things that came out is people were saying different types of structures can optimize for handling different types of documents. So,
narrowly chartered groups actually work really, really well for, projects that are large, like DELEG is the quintessential example. I think everybody I heard said DELEG was a good example of something that had to be out on its own. Whereas, other work really should progress in a smaller working, or a wider working group because it didn't need its own long-term discussion. The last two are crossed out because they were originally sort of consensus that we found, and then we found that there wasn't consensus after writing the draft and releasing it, and that's whether DNSOP should be closed down itself or whether it should be rechartered. So I don't think, and I use the word consensus. I'm trying not to use the word consensus because it doesn't match the IETF's consensus model of how we went about it. So consolidated opinions or something like that. We didn't go through IETF last call and all the other things. So I may have gotten yelled at about that. So there's a bunch of stuff that didn't get commonality either. Like, should it be rechartered versus closed? Some people thought closed would be better because it's a clean slate. Other people thought rechartered would be better. The one thing that was sort of common was that DNSOP is already the perfect name for an operations group, although adding an S to that sort of works around that problem a little bit. The other interesting one was whether or not everybody would attend all the groups and watch all the mailing lists. And there was definitely a split there. Some people were, very much indicated, I'm already going to have to do everything. This is not going to change anything. It's going to be equally as frustrating. Now I have like 3 mailing lists to watch or whatever. There was other people that were not quite as vocal in those arguments that did come to me, privately and said, you know what, I actually will follow one much more closely, or I may not even subscribe to one of them. So different people really do have different thoughts on that. So there's not a collective, opinion on that. So remember that this slide is about the lack of common opinions. And then little feedback was received about some of the groups, so I didn't, we weren't able to talk about DNSSD or regex or something like that because we had no information. So there's other, kind of cases of that where all the things that we put into the draft were things that we heard enough information that we could distill something out of. So there are sort of 3 recommendations I'm going to talk about here today. They are not alone. The document has more in it, so I suggest that readers, that people do go read the document. So first off, split DNS development from operations was generally a something that almost everybody agreed to. There's definitely some opposition to that, however. And the real, the important thing is that there needs to be a clear line between them, but that's also impossible. So what we thought was, well, as a starting position, we could ask, is there special processing code? And if so, then it goes to devel, otherwise it goes to ops. But area director management and working group cooperations between the chairs is going to be absolutely critical if the IESG takes this on. So strong leadership is going to be needed, or people that are willing to work together and shuffle things around and not fight over turf. Let's put it that way. And then, groups can be managed differently, and that can be a benefit. Finally, create a DNS dispatch group. A lot of the concerns that were brought forward for doing this were relating to, it'll add one more step in the process. It'll take up one more meeting slot. It'll, slow everything down by 3 more months. And so our thoughts around that as the authors were, well, let's make it mostly online. A lot of DNS dispatch could be done online, either in the mailing list or in an interim, and only in rare cases does it really need to go to a person or to an in-person meeting. And then finally, a dispatch is not a decision. So it really tells people where to take their work, just like existing dispatch groups. You still have to go through the adoption process in a group in particular. Then finally, as I already indicated earlier, group and people management is going to be critical. That's going to involve chairs that are willing to work together. It's going to involve area directors that are very careful overseeing all of this, especially in the DNS dispatch group. So everything's going to have to be a little bit flexible. Documents could even need to move from one to the other in really rare cases, but I'm sure to say that it'll never happen, I'd be very wrong. So next steps, as I said, I'm going to provide the final internet draft to the ISG, and the ISG is going to choose to do with it what they will. If you have final comments, please send them, to me immediately if you think something's really wrong in my conclusions. But again, anything in there, the three of us really tried to distill from feedback we heard. We were very unbiased in our processing of all this. With that, any questions?
Thank you, Wes. Any question? Eric?
Hi, Wes, and thanks for running and from one floor to another one just on time. Can you go back to slide 8? Wes, I think it's possible on the controller, Carlos.
That's 8.
Oh, that's you. Okay. Can you go back to slide 8?
That is 8.
Oh, okay. So far for me. So I think the 2 points, right? The 2 last points are obviously the same thing. I don't think everyone will need to attend every group because not everyone was interested in the NSSD, which is clearly a proof that not everyone needs to go to the NSSD.
No, those are 2 different points. So so the second one, I understand your confusion. Now that I've heard what you just said, my slide could be improved. So this is the difference between DNS op versus DNS protocol development. And some people thought, well, if there was an operations thing that was doing algorithms and there was a protocol thing that was adding new RR types for DELEG or something, or some new special thing, they would have to go to both anyway. So that's not helping them. But other people specifically said, no, it would help them because they're developers, so they would watch development stuff much more focused on a daily, hourly basis, and maybe once every couple of weeks look at the operations list. Or other people actually said, no, I'm going to ignore operations and only go to protocol or vice versa or something like that.
Okay, thank you. And now with my idiot, thank you for the job done. The IG will be using this for sure, or reading it with interest. Thank you.
Thanks, Warren Kamari. So first off, thank you very much for doing this. I know it was a chunk of work, and what you did was, reflect what everybody told you. However, something that Eric said kind of made me worried, which is, as a lot of people said, they will follow the protocol development part and not the operations part, or the other way around. And that's my concern, right? Yep, I know we've had this conversation. You did what the community said. My concern is we're going to end up with something like V6 ops and 6-man, where there's a lot of disagreement. And there's ADD and DNSSD. That was probably Jen in the background being like, no, there's never any drama there. Like DNSSD, deprive, deleg, DNSOP, and things are going to end up in one, and people in the other groups simply won't hear it. But, whatever. Oh dear, I've triggered Jen enough that she's come to the mic.
So I do think that I absolutely recognize that's a concern, and you're not alone in your opinion of that being a concern. And that was already a concern. Some people actually, the one side group that was created that people weren't 100% sure should have been a side group or not was actually ADD. And I will tell that in aggregate, right? Most people said ADD actually should have been a side group, but there was a few holdouts to that, unlike DELEG, right? So there's always going to be that problem of how many times is there DNS work happening in, completely different areas of the IETF, or how many times is the HTTP directorate called in at the last minute and found that, you've really messed up your HTTP draft, or, some element in it. That's an issue, and that's where the DNS directorate, I think, will help there some too. But fair point. Jen?
I didn't want to say anything initially because I guess you talk probably to people going to 6-man and V6 ops, but actually my experience is that I do see more or less the same people in 6-man and V6 ops. It's just people being active, people going to mic are more or less the same people. And I personally had a lot of interesting experience with drafts which overlap. So one of my drafts, as Warren probably knows, was going there and back again because we couldn't decide if it's V6 ops or 6-man, right? So I sometimes wish we had one group, not 2, right? Because especially like for historical reasons, right? And like whatever ISG decides to do, I do not envy them because it would complicate their scheduling. And ideally, I guess they might want to put operational group in the schedule before protocol development 1, because it's what we were doing with 6-man for the last couple of years. I always ask to put 6 months after V6 ops, because for many drafts, we want V6 ops to produce a problem statement, and then you can go to 6 months and discuss if it should be solved. And drafts which are not solving operational problems should not, in theory, appear in protocol development one. So it's just a consideration about scheduling, which will be much more fun now if they decide to split.
Yeah, that's an interesting point. So I will say, I came in here and Jen already had the slides on the screen, and I thought I was at the end of the session, so I rushed through a lot of stuff, not realizing you guys are actually a half an hour ahead of schedule, right? So let me bring back one important point, which is one of the reasons people thought the separation would be good was not because they were going to be able to stop following one. That was actually not the primary point. The primary point people brought up is they felt the operations drafts were being pigeonholed into, were being delayed because so much larger topics were happening, you know, that were DNS related, and because they didn't have their own space, they were progressing more slowly than people thought that they should, because very simple documents that are operational based, whether it's a new cryptography algorithm or you know, minor changes to things, should generally be able to flow through an operations group that is tightly focused around that differently. Similarly, you know, one group might want running code and the other one might not. There's a bunch of little tiny management differences that people pointed out. So that's actually the compartmentalization, I think, was one of the biggest things that we heard from people that would be helpful. But there's people that disagree with that statement too. So, Eric?
Yeah, and first I fully support Jen's statement about getting the ops part before the development part. This is simply smart. Now,
Nobody
to come back
that.
on, oh, sorry?
Nobody mentioned that yet, so I actually appreciate that
6
feedback.
months been doing it for a while, yeah. So
No, you need to put something on the draft for this for sure, even if it's very tactical. Now, if you remember as well, my understanding of creating ADD and DELEC outside of DNSOP, that's because there were two big, like you said, big boats that if we cannot ship at the same pace as DNSOP, and or ADD, which was more controversial at the beginning, right? So we wanted to remove as well, not only the work, but also the controversy outside of DNSOP. And,
yeah, and there is a section in the draft that talks about that. It's not really in the presentation or the discussion I just gave, but there was generally wide agreement that really large problems, and DELEG is the quintessential example, really needs to be in its own thing. But.
Yeah, because not everyone is following all of them for good reason as well. Thank you.
Thanks. I see no other hands, so.
Okay, thank you, Wes.
Okay.
Okay, I think we're done. Oh, one more.
Just one more point, Wes, if you are still online, getting small groups, right, with kind of different conflict, also allow the scheduling exercise. And Warren in the room will remember that when we scheduled the agenda for this week, we got multiple conflicts. So if we split in small group, maybe with less conflict, that having a big group with thousands of conflict makes things way easier.
Yeah, the other thing to note about, especially related to Warren's concern, is one advantage of the dispatch function would be that it would be an indication of where a draft was going to go. So it doesn't state it explicitly anywhere because nobody stated it explicitly enough for us to really write it down. But everybody DNS related should probably attend the dispatch mailing list and interims so that they could see what direction or to what group something they really cared about was gonna fly. There's not a huge amount of information or comments that distills from, but there definitely was some of that.
And the last point about the dispatch, even if you dispatch one draft like the DHCP thing that we got here in INTAREA, we can move it to the DHC working group and back here. So don't be fooled by, and you know it, right? But don't be fooled by the working group being a silos and drafts being stuck into one working group. We can move it. Just
yeah, and both the document and my slide said that you know, there will probably be those rare cases where something will move because, you know, it changed from, well, it seemed like an operationally simple comment and, you know, thing until we ran into real issues, and now it has to go to development. But,
yeah, look about the NS multi-queue type, right, for instance. Okay, thank you again.
Bon. Okay, thank you very much, gentlemen. See you in Vienna. Thank you. Thank you.